Alright, so this is a video on how to name acids and bases. And we're going to do these examples. I'm going to do some of the examples on the paper and then I'll turn you loose and you can do the rest of them. So the first thing you want to do is to decide whether something is an acid or a base. Remember that I'm going to do this letter A right here. If I have hydrogen as the first element in my compound, then it's likely to be an acid. In this case, everyone we'll look at will be an acid. So once I know that it's an acid, I'm going to look at my rules, which you will have on the test. Remember that if it's an element by itself, which we would have an I or has an IDE ending, we're going to use the prefix hydro, insert the element that's by itself, or the one that's not a hydrogen, add IC to the ending, and that's going to be acid. If the ending is, when you look at your polyatomic ion, if it's ATE, you're going to insert the name of the polyatomic ion, drop the 8 off, and add ic, and that'll be an acid. The last one is if it ends with ITE, the polyatomic ion, you're going to drop the ITE and add OUS. So you're going to put the name of your polyatomic ion and add OUS. And that's going to be acid. The bases are much easier to name. So let's go back to our letter A here. So we've got hydrogen, which is going to make it an acid. And we have fluorine. Well, the H is going to be our cation. Fluorine is going to be our if I can't talk, our anion. And so when you look at the periodic table, you're going to see that's just an element by itself. It's just one thing, so it's not a polyatomic ion. So to name this, we're going to follow the IDE rule, and it's going to be hydrofluoric acid. Now to name a base, you can see that we don't have any hydrogen as the first element, but we have OH, which is called hydroxide. Whenever you have a base, you're always going to have OH. So these are easy to name because you're just going to name the cation. In this case, it's potassium. And then you name the anion, which is always going to be hydroxide. So whenever you have OH, this is always going to be a base. Whenever you have hydrogen, it's always going to be an acid. Let's go down to the next one. So you're going to need to look on your polyatomic ion sheet. We know this is an acid because it has hydrogen as the first element. And now you're going to need to look up SO3. And when you look up SO3, you'll see that this is called a sulfite. So now we're going to drop off the ITE and change it to OUS. So this will be sulfurous acid. This middle part here, if you get this incorrect spelled, I'm not going to mark it wrong. But you need to be sure to identify that it's sulfur and it's the OUS ending. Let's take a look at the next one. The first thing I can see immediately is that this must be a base because it's got hydroxide. And I'm just going to name the cation. So that's going to be calcium. And that polyatomic ion is hydroxide. Let's go to these over here. This has to be an acid. Because it's got hydrogen. Here's my polyatomic ion, so I need to look at the back of my sheet. And this is a nitrate. So it ends with, here's nitrate. Ends with ATE, so I'm going to change 8 to ic. This is going to be nitric acid. you should be able to do F, G, and H. I'm going to go ahead and pause the video for just a second, and then I want you to go ahead and do F, G, and H, and then I'll show you what the answers are. All right, here you can see the answers for F, G, and H. So now I'm going to turn the page and go to the next examples. And we'll do, well, go ahead and I'm going to pause the video here, and you go ahead and do I and J also. All right, now you can see the answers for I and J also. Now to go the other direction, to go from the name of the acid to the formula, it's a little bit more complex, and you're definitely going to need to have that polyatomic ion sheet sitting next to you to do these. I'm going to pause the video while I grab mine. All right, so now I've got my periodic table, and on the back I've got that list of polyatomic ions. Remember, a polyatomic ion is an ion that has more than one atom, and they're going to be all combined, and these are the ones that we're going to be putting in parentheses. So the first one is an acid. Well, if I know it's an acid, then it's got to have that hydrogen. So I'm going to write H. Now I'm going to look on my polyatomic ion sheet, and I'm going to look down, and the second one down says that it's an acetate. Well, if it has an ic ending, then it must have started with an 8. So now I've got the acetate, and I'm just going to write down the formula. C2H3O2. Now the last step for this is to make sure that my charge numbers, have been crisscrossed. Well, hydrogen always has a +1 charge. The acetate, you can see, has a -1 charge. So what I'm going to do is just make sure this is balanced, is I would crisscross the charges. The 1 from here would go to the hydrogen. The 1 from the hydrogen goes to the acetate. So when I would write this, it's a 1-to-1. I never write the 1 as a subscript, so the correct final formula would be H. C2H3O2. Now you don't have to use parentheses. I like to put the parentheses there just so I always know I'm dealing with a polyatomic ion. But if you leave the parentheses off, there's nothing wrong with that. The only time we have to have parentheses is, of course, when you have a subscript behind the polyatomic ion. Let's go ahead and check out B, magnesium hydroxide. If it's hydroxide, that's going to be a base, of course. So now I'm going to write down my magnesium and then look on my polyatomic ion sheet, and I can see that it's OH, and it has to be OH because it's a base. Now I have to do that same step. I've got to look and I've got to find magnesium. And when you look on your periodic table, you'll see that the charge that's above magnesium at the top of the column is a +2. OH always has a -1 charge. So I'm going to crisscross the charge numbers. So you only do the numbers. You don't do the positive and negative. You just bring the number across. So what this means is the correct formula for this is going to be MgOH. And that 2 needs to go on the outside of the parentheses. Later on in the class, we'll be discussing why we're doing this. But right now, you're just crisscrossing charge numbers, not the sign, not whether it's positive or negative. You're just taking those numbers and crisscrossing them. If it's a 1, you don't need to write it. Let's look for hydrobromic acid. So the first thing I see that I've got hydro, and I've got ic, and then I've got bromine, or the BROM. I know it's an acid because it tells me it's an acid, so my first thing's going to be hydrogen. Now I'm going to look on the periodic table, and I'm going to look up what bromine would be, or bromide. Well, that's Br. The next step is to look the charges up. Hydrogen always has a +1 charge. The bromine, you can see, has a -1 charge, which means for my formula is just going to be 1 and 1, so it's going to equal HBr. Again, you never need to write the ones. Let's try gallium hydroxide. I'm going to write down gallium, which is Ga, and then write down the polyatomic ion hydroxide. I look on my periodic table and I see that gallium has a +3 charge. That 3 is on the top of the column of your periodic table. Hydroxide always has a -1 charge. Whoops, wrong color there. I'm going to crisscross the charge numbers. So the 1's going to go to the gallium, the 3 is going to go to the hydroxide, which means that my final formula will be GaOH3. Let's try, I'm going to skip the E, F, and G, but I am going to show you how to do H. H is a little different because we've got that Roman numeral 3. Well, first thing I'm going to look at is this is hydroxide, and I've got iron. So I'm going to go Fe, here's my iron, and I'm going to put my hydroxide. Now, if you look for Fe to find the charge, you'll see that there's no number that's above it, because anything that's in the middle there, those are transition metals, and they can have different charges. So what the Roman numeral 3 is telling me is that the charge on the Fe is a +3. If this was a Roman numeral 2, that would mean the charge on the Fe, or the iron, is +2. This is actually telling you the charge on cation, and that's always going to be your cation. So my hydroxide always has a -1 charge. So now it's just the same thing. The 1's going to go with the Fe, the 3 is going to go with the OH, and so my final formula is going to be FeOH3. All right, pause the video for a second and I'll give you the answers so that you can check them. So you're going to do E, F, and G. All right, and there you've got your answers for the 3 missing ones. All right, I hope you found that helpful. If you have any questions, let me know.